Section 4.2.3 Periodic Graphs and Phase Shifts. The distance that one graph must be shifted to the right or left to coincide with another graph is called a phase shift. Consider the parent functions of sine and cosine. What phase shift would we need to make the cosine graph equal the sine graph? So let's go ahead and look at our parent graph, y equals the sine of x. For this parent graph, recall that if we add or subtract 2 pi to our angle measurements that we have, which is our x-axis, we will get coterminal answers. So if I have y equals the sine of x plus 2 pi, and we take our entire graph that we have here and we shift it to the left 2 pi, notice that it still looks like our parent graph, y equals the sine of x. The only difference is that now we had shifted it over. So I know that this value of negative 2 pi is coterminal of 0, 3 pi over 2 negative is coterminal of pi over 2, and so on. So this was a shift to the left 2 pi. So if we want to go back and think about the questions that we have, if I want to turn the cosine graph into the sine graph, then notice I would have to take this graph and shift it to the left pi over 2. So that means that the sine of x plus pi over 2 is equal to our cosine of x function. Because remember, the cosine graph starts at 0, 1 here, and then it has pi over 2, 0, and so on. So if I want to make the cosine graph into the sine graph, well, then of course I would have to shift this back to the right now, pi over 2. So if I move that to the right for the cosine, so I could say that the cosine of x, and right would be minus pi over 2, is equal to the sine of x. So that's what we're going to be looking at today. So let's go ahead and write that down. So if we shifted the cosine graph to the right, pi over 2, then we know that the sine of x is equal to the cosine of x minus pi over 2. And if we move the sine graph to the left, pi over 2, then that would be equal to the cosine of x. So for our combined transformations, we have our general equation that we have looked at before. So f of t is equal to, and I probably should have said instead of f of t, f of x, because we're using x in the equation. So f of x is equal to a times the sine of b times x minus c plus d. And remember, notice that our b value is in factored form, which we always want to have. So we know that the amplitude is the distance from the midline up and the midline down, and it's always the absolute value of that a value that we have in our equations. Then we have our b value, which helps us find, we remember, the frequency. So we know that the b value is equal to the frequency. So basically, remember, it tells us the number of cycles from 0 to 2 pi that we are making. And so we have the equation that our b value times the new period that we have should always be equal to 2 pi. So if we solve this equation for the period, we would get 2 pi over b, and we can also solve the b value for 2 pi over the period. So that's what we're using here. And then our phase shift is the c value. So remember, when it's minus, it's to the right, and if this was a plus sign here, that would be to the left. And the vertical shift is moving up or down d units. So here, recall that also this distance, which is the period, is the horizontal distance that it takes to complete one cycle. So in this case, remember that distance is always positive. That's why our period is going to be positive and our b value is going to be positive. So those are things to remember as you're writing your equations. So we do have some helpful hints of things that we can write down. We remember that our amplitude is our maximum minus our minimum divided by 2. And of course, we're using our y value. So our y maximum minus our y minimum divided by 2. And the b value is equal to 2 pi divided by the period. And of course, remember, we can find the period by doing 2 pi divided by our b value. Our c value is our phase shift. So if it's a cosine graph, then you're just looking for a maximum point on your graph or a minimum point. If it is a sine graph, notice that for the sine graph, the place where we want to find is where it crosses the midline, which we've talked about before. So notice that if this is the maximum and this is the minimum, that sine is going to always be in between. So remember, to find the average, you add something together. And we're looking at the x values, so it would be the x maximum plus the x minimum divided by 2. And again, this would be for the sine function. For cosine, you just look at the max or minimum values. And then, of course, the vertical shift, remember we said, was the y maximum plus the y minimum divided by 2, because it's always the average in between for your amplitude going up or going down. So let's go ahead and do some examples. It says determine the period, amplitude, and vertical shift, phase shift, and key points for the graph of this function that we have here. So the first thing you always want to do is make sure that if that b value is not in factored form, that you want to go ahead and make sure to factor that out. So that's the first step. So I'd have y is equal to 1/3 times the sine, and then we're going to factor out that -2. So when we factor that out, that becomes t, and if you factor negative divided by a negative becomes plus. And so remember, when you're factoring something out, you're really dividing out, so plus 5/2. And you can always check your work, because if you multiplied this and distributed back in, you would see that you would get -5 here. So the amplitude, we know, is the absolute value of 1/3, which is just 1/3. And remember, we know that that is a vertical compression by 1/3 on your graph, so you'd be changing all your y values. The period you have to get by looking at what your b value is. So in this case, our b value is going to be equal to 2. Remember that negative actually does something different, that reflects it across the y-axis. So that b value, because it is equal to 2, that's going to help us figure out what the period of our function is. This 2 means that from 0 to 2 pi, we would actually have 2 cycles of our graph. So the period is equal to 2 pi divided by b, which is 2 pi divided by 2, which is equal to pi. And I'm going to make a note that this means we have 2 cycles from 0 to 2 pi. So that is a horizontal compression by 1/2, and we learned that in the last chapter. And we also, that negative is a reflection across the y-axis. So then for the phase shift, it would be this value right here. So remember, we're calling that C. So our phase shift would be C is equal to, and remember that in our general equations, if we go back up here, it's always x minus the number. So in order to get a plus there, our C value would have to be negative. So that means that C is equal to -5/2, and that's why this is actually moving left 5/2. There is no vertical shift because there's no d value, that's just +0, so the d value would be equal to 0, or you could say none. And then your key points, remember that your key points are your maximums, your minimums, and your intercepts, or where your graph crosses your vertical shift, so the midline. And in this case, that means for this graph, we have to take the period, which is pi, and we divide it by 4, or dividing by 4 is the same thing as multiplying it by 1/4, and we get pi/4. So that means that on our graph, when we're graphing this, remember that our key points are going by intervals of pi/4, and that's what I would count by on my x-axis as I'm writing them down. So let's go ahead and do some practice of writing the equations of graphs. So if I want to write these equations as a graph, I'm just going to go ahead and first write down my general equation so I remember what I need. So we have y is equal to a times the sine of b times x minus c plus d. So that would be for sine, and then cosine would be the same thing except for with cosine here. So y equals a times the cosine of b times x minus c plus d. And again, recall that I'm always factoring out that b value. So let's go ahead and look at the graph that we have here. So first I need to find what my a value is, so that in order to find that, I need to look at my maximum and my minimum points. So my a value is going to be, of course, recall that it's your y maximum minus your minimum. So your maximum in this case would be 2, and the minimum is -2. So 2 minus -2 divided by 2 would give me my amplitude. So that's 4/2, which in this case is just equal to 2. My vertical shift is your maximum plus your minimum divided by 2. So 2 plus -2 divided by 2 would be 0/2, which is just 0. And then I need to figure out what my b value is. In order to figure out your b value, you need to figure out what the period of the function is. So to find the period, you would want to figure out what the distance is from a maximum to maximum, or you could do a sine graph. So in this case, it looks like we can see that the period's going from here to here. So it looks like from if you look at those values that you have, this is a point at 4, 2, so that means my period is equal to 4. And you can kind of double check yourself, because if you can't tell, we know that from a maximum to a minimum is going to be half of a wavelength. So from here to here, if that's a distance of 4 minus 2, which is 2, then you know from here to here is also 2. It's easy to tell right now because this is on the y-axis, but again, if it wasn't, then you can use the fact that you know that the distance from here to here is 2, so the period is 4. So then again, to find your b value, remember that the b value is equal to 2 pi divided by your new period, which is 4. So 2 pi divided by 4 gives me a b value of pi/2. And then the other part is I need to see if I have a phase shift that I need to worry about. So let's go ahead. I'm going to erase some of this so that I can put my midline on my graph, because that kind of helps me figure out where I'm going in between. So here's my midline. And I can even count up 1, 2, and down 1, 2 to check my amplitude is correct. So this one's nice because the graph on the y-axis is starting at a minimum. It's not starting on your midline. So because it's starting here, then I know that from here to here makes a cosine wavelength. But because it's opening down first, we know we have to have a reflection. So let's start off with y is equal to -2 for that reflection because it's starting down, times the cosine of my b value, which is pi/2, times x. In this case, we don't need a phase shift, so you don't really need to write x minus 0. You can actually just write pi/2x, and then plus my vertical shift, which in this case is 0, so you don't really need to write plus 0. So this is one possible equation. Of course, I don't have to start there on my graph. I could actually have started up here at a maximum point. So if I would have started up there, then notice that since my graph would be starting up and then going down, then we know that this would be an amplitude that's positive. So you would have 2 times the cosine of pi/2 times x, and we would actually need a phase shift because we're moving, normally our cosine graph would start on the y-axis, so to move it over here, we actually had to go to the right 2, so x minus 2, and then again plus 0. So even if you were to graph these in your calculator, you would see that both of these graphs give you this graph that we have right here, which is have many possible answers for our solutions. So now let's go ahead and think about our sine graph. So remember that a sine graph has to start on your midline. And in this case, if I look at the first place that I have that's positive, would be right here. So if I start there and go to here, you can see that's your sine graph. So for this, because it's going up first, I don't need a reflection. So I have y is equal to 2 times the sine of pi over 2 times x. Now we need to figure out what that shift over is. Well, since I know that the period of my graph is equal to 4, that means that my key points, remember you take the period and divide it by 4, so 4 divided by 4 would give me 1. So since my key points are going by 1, then I know that that's actually at 1, so x minus 1, and then again plus 0. So this would be a possible sine graph. Of course, I could have also started my sine graph right here. And if I would have started there, then I would have had a negative in front here. And then instead of x minus 1, because my graph would be shifting to the left, I would have to use x plus 1. And if you can't tell on your graph what your values are, in order to find your sine graph, you could always use your max and minimums to help you if you know where they're at. So if I know this is at 0 for an x value, and this x value right here is 2, well, I know that my sine graph has to be in between that. So how do you find something that's in between? You're adding them together, divided by 2, so that's where you get the 1 from. So let's go ahead and look at the second graph here. So on the second graph, we want to do the same thing. We want to find a sine and a cosine graph. So first I want to look at my amplitude. So the amplitude we know is equal to the maximum minus the minimum divided by 2. So the maximum is 9 and the minimum is at -3. So maximum minus -3 divided by 2. So that would give me 12 over 2, which is equal to 6. Then I could also use my graph and just count down 1, 2, 3, 4, 5, 6 right here. So I know that's where my midline is going to be. And I can also check the other side, 1, 2, 3, 4, 5, 6. So my midline should be at 3. So just to double check, we can do the maximum plus the minimum divided by 2. So 6 divided by 2 gives me 3. So that checks out. So I always like to draw that on my graph, because I know that's where my graph is oscillating back and forth between, so up and down. So now that I have that, I need to figure out what my b value is in my equation. To figure out my b value, I need to figure out what the period of the function is. So I need to figure out what one wavelength is. Now this one's a little bit harder because, as you can tell, we're not starting on the y-axis on a max or a minimum point, and our graph is not going to start at the y-axis for a sine graph. So to find the period, you would actually really need to use your x-coordinate of your max and min that were given to you. So in this case, I can see that I have an x value of 2.5 and a y value of 0.5. So I know that that's going to be half the wavelength of my period. So if I just find the distance that is from these 2 points, I'm just subtracting. So if I do 2.5 minus 0.5, I know that's equal to 2. So that's half a wavelength. So it gets a full wavelength, I need to add another 2 to that. So then that means that the period is really equal to 4, just like my last one. So we know if the period's 4, like we said in the last one, that means my b value is 2 pi over 4, which is actually equal to pi over 2. And then I need to figure out what my phase shift is. So I'm going to start off with this one with a cosine graph. So you could start your cosine graph on a minimum, or you could start on a maximum. I'm just going to use the maximum this time first. So like we were starting from here. So that would be, since it's up, a positive amplitude. So y is equal to 6 times the cosine of our b value, which is pi over 2, times x. And to get here, if our cosine parent graph normally starts on the y-axis, I have to move that to the right 2.5, so minus 2.5. And then in this case, our vertical shift is plus 3. Of course, that's just one possible equation. I could have also used this point down here that we have at 0.5. And of course, since that's down, my equation for that, if I started there instead, would be y equals -6 times the cosine of pi over 2 times x minus 0.5 plus 3. So those are two different options. And of course, we could really start at any max or min on our graph and do the same thing. So then for the next one, if we want to find a sine graph, sine graphs have to start on the midline, so somewhere right here. So it's kind of hard to tell where that's at. So if I'm unsure, I can use my max and my min values to help me. So it looks like it's at 1.5, but we want to double check. So remember, to double check, you're taking the average of your max and your min x values and divide it by 2 because you know it has to be in between. So in this case, if we have the x value of our sine graph would be at the 2.5 plus the 0.5 and divide it by 2 because you're looking at the in between those 2 points. So when I do that, I get 3 over 2, which is equal to, of course, 1.5 as decimal. And so that makes sense then because you can see here at about 1.5, we have our sine graph starting. So if I start there, then that would be my first sine wave. And so that means in order to get there from the sine graph, normally it starts here at on the y-axis at 0, 0, but we've moved it up 3. And of course, to get over there, we'd have to move it to the right 1.5. So one possible equation would be y is equal to 6 times the sine of pi over 2 times x minus 1.5 plus 3. And of course, we could also figure out, since we know the period is 4, our key points, are going by 1, we could also figure out what this is by subtracting 4 from the 1.5 to figure out that that's going to give me this value and start there with our sine graph. And then, of course, that would be going down first, so should we need a negative? So for these, again, there's many possible answers that you can have. These are just a few of the ones that we have chosen. So now let's go ahead and take a look at this equation and sketching a graph. So for this, remember, first thing you always want to do is factor out that b value. So I have y equals 3 times the cosine of 1/2 x. And remember, when you're factoring something out, you're really dividing it out. So if I divide pi over 2 by 1/2, that would really be like multiplying by 2. So minus pi and then minus 2. And you can always check your answer because 1/2 times x is 1/2 x. 1/2 times negative pi gives me negative pi over 2. So my amplitude is 3. My b value is 1/2. My c value is pi, so we're going to the right. My d value is equal to negative 2. So I like to think about my transformations as I'm doing this, but I also need to figure out a couple other things before I do that. So I need to figure out what the period of my graph is, because remember the period is equal to 2 pi divided by your b value, which is 1/2. So 2 pi divided by 1/2 is the same thing as, remember when you're dividing by a fraction, you multiply by the reciprocal, so 2 over 1. So that gives me 4 pi. So that's my period. And then I also need to figure out my key points for my graph. So my key points, remember, you take the period and divide it into 4 equal parts. So we have the key points are equal to 4 pi divided by 4, which is equal to pi. So on my graph, I'm just going to count by pi's. Now that I have my key points in my graph, I also want to label my y-axis. So I'm just going to 1, 2, 3, 4, 5 here. Negative 1, 2, 3, 4, 5. And then I also like to write out my transformations because we learned how to do that. So that helps me graph these. So I know that because my b value is 1/2, that would be a horizontal stretch by 2. Because remember, that means that from 0 to 2 pi, we have a half a cycle. So then that means this c value, since it's pi, we're going to the right pi. And then we are vertically stretching it by 3. And we're moving it down 2. So for this graph, we've already taken care of our horizontal stretch. We did that when we did the new key points on our graph. So I'm going to go ahead and start off by thinking about my cosine graph. So cosine normally starts here at 1, then it goes down to 0, negative 1, 0, 1. Of course, it's a little bit different because we changed these key points that we have. So for this, just kind of draw it in like you normally would. Because again, we've already taken care of the horizontal stretch, because notice that from 0 to 2 pi, it's just half of my graph now. So from 0 to 4 pi, it was my period. So now for this, we're going to move our graph to the right by pi. So you can move it now if you want to, or we can move it after we do the vertical stretch. But I'm going to go ahead and move this now. So if I move that to the right pi, now it would be here. Then remember that the next transformation that we made would be a vertical stretch by 3. So that's changing your y value. So I'm going to multiply those by 3. So 1 times 3 is 3. and then 0 would stay at 0. This would be negative 3, 0, and 3. So that would be my next part of my graph. And then we're going to take that graph and actually just move it down 2. So down 1, 2. So this would be the new graph that I would have. And I'm actually going to draw my midline in. So my midline, remember, is at negative 2, because I know my graph should be oscillating back and forth between that. And let's go ahead and sketch over this one to make sure. So if we keep going, I know it's just going to keep repeating. So this would be at 0. The next one here would be at that place. Then we have 0, or sorry, not 0, I should say negative 2. And this one would be up here. So again, I'm just repeating all of these values. And now we can see that this would be the new graph. So if now you don't need to write out all those transformations unless it kind of helps you, but you should be able to try to maybe graph this without doing all that. Normally, if I start off my graph, what I would do is I would actually just draw the vertical shift in, and then I would think, okay, so this is a cosine graph. We stretched it. We moved it to the right. So as you can see, if I were to go back here, just moved it to the right pi. And then you can kind of check your answer by thinking about a table if you want. So I'm going to go ahead and make a table here just to kind of show you what I mean. So for my table, I know that my parent graph values normally are 0, pi over 2, 3 pi over 2. I'm sorry, pi, then 3 pi over 2. So pi, 3 pi over 2, and then 2 pi. So what did we do to those x values? We did a horizontal stretch by 2. So that means, remember, when you're horizontally stretching something, you're multiplying 2 by all your x values. So that would be 0, and 2 times pi over 2 is pi. This would be 2 pi. 2 times 3 pi over 2 would be 3 pi. And this times this would give me 4 pi. That's why we got all our new key points right there. And then what did we do next? We took all those key points and we went to the right pi. So that means I'm adding pi to all these points. So 0 plus pi is pi. 1 pi plus another pi would be 2 pi. 3 pi, 4 pi, and 5 pi. Then for the next part, we are doing our y values. So that means I'm just going to plug all these into my equation. So we're actually plugging this into our function. So I'm just going to write f of x here instead of writing that all in because I don't have room. So think about if I were to plug into my equation pi. So if I plug that in here, I would get pi over 2 minus pi over 2, which is 0. So we're just kind of going back down through here. And then the cosine of 0 we know is equal to 1. 1 times 3 is 3. And 3 minus 2 gives me a value of 1. And then I can do the same thing. If I plug in 2 pi here, that would be 2 pi over 2 minus 1 pi over 2. So 2 pi over 2 minus 1 pi over 2 gives me pi over 2. The cosine of pi over 2 we know is equal to 0. 0 times 3 is 0 and minus 2. And then if we keep going at 3 pi, if I plug that in, 3 pi over 2 minus 1 pi over 2 would be 2 pi over 2, which is pi. The cosine of pi we know is equal to -1, and -1 times 3 is -3 minus 2 would give me -5. So again, all I'm doing is plugging those values in for x and then solving for y. So the next one would be -2, and this one would also be a value of 1. So you can kind of check the points that you have. So the first point we have would be pi and 1. So I can see here at pi, I have this value of 1. At 2 pi, I have -2. So 2 pi, -2 is here. And then at 3 pi, I have -5. 4 pi, -2, and 5 pi, we have 1. Again, I'm just checking my answer that I have. So there's lots of different ways that you can graph this and look at it. So this is just one way. And like I said, a lot of times I just will graph the midline and then think, okay, well, from the midline, because my amplitude is 3, I know I have to go up 1, 2, 3, and down 3. We shifted our graph to the right. So whatever helps you. So bring this with you to class, and we're going to do some more practice tomorrow.